Freezing November wind howled outside a drafty Athol boarding room in 1877, where Laroy S. Starrett sat staring at foreclosure notices. He had lost his family farm to bank debts, lost his life savings to a failed meat-chopping enterprise, and had been ruthlessly ousted from his own workshop by wealthy financial backers who considered his ideas worthless. He possessed no capital, no factory, and no influence. Yet laid out across his rough wooden table was a single hand-carved wooden pattern for a mechanical instrument that traditional toolmakers insisted was impossible to manufacture at scale. It was a revolutionary measuring tool designed to combine a tri-square, a miter square, a depth gauge, a spirit level, and a steel rule into a single drop-forged device capable of measuring metal down to 1/1000th of an inch. Local machine shop owners mocked the concept, claiming that combining multiple functions into one tool would inevitably introduce structural flex and ruin accuracy. They argued that serious craftsmen would never abandon their heavy cast-iron tri-squares for an unproven wooden prototype built by an evicted farmer. Standing in the freezing room, Starrett ran his thumb along the hand-scraped edge of his prototype blade and made a silent vow. He promised that this single piece of steel would set the absolute global standard for human precision. The steel did not lie. Welcome to Rivet and Rebar, where we dig into the industrial giants and mechanical sagas that quietly built the modern world. If forgotten industrial history and precision engineering inspire you, take a moment to like and subscribe to support our channel. Picture the Miller's River Valley in the late 19th century to understand where this saga truly began. New England was rapidly transforming into the mechanical engine of the Industrial Revolution. Along the riverbanks, heavy timber water wheels spun continuously, driving leather belts, line shafts, and drop hammers inside soot-stained brick factories. The air smelled of wood smoke, coal gas, and sulfurous cutting oil. Born in 1836 on a rocky farm in China, Maine, Laroy S. Starrett grew up enduring relentless physical labor. Farming in stony New England soil was a grueling struggle against nature, requiring endless hours of clearing boulders and plowing frozen earth. But while other young men accepted the farm as their permanent destiny, Starrett was obsessed with the mechanical geometry of tools. Innate mechanical genius and spatial visualization set Starrett apart from traditional farmers. Whenever a farm implement broke, Starrett did not just patch it, he redesigned it to function smoother and last longer. By his early 30s, he had managed to buy his own farm in Athol, Massachusetts, while spending his nights inventing labor-saving machinery. He patented a radical mechanical meat chopper that gained commercial attention, prompting him to sell his livestock and invest everything into factory production. But Starrett was a naive businessman among wolfish investors. His financial backers manipulated the company's stock, stripped him of his patent rights, and forced him out of the firm entirely, leaving him bankrupt and homeless. Devastated but unbroken, Starrett refused to accept defeat after losing his farm and patents. He understood that while corporate raiders could steal money, they could never steal his mechanical genius. He rented a small, unheated workshop space in Athol, borrowed a single belt-driven lathe, and went back to work. He observed that machine shops were rapidly expanding across America to build locomotives, steam engines, and textile machinery. Yet the machinists building these complex mechanisms were severely hindered by primitive measuring equipment. Mechanics relied on heavy, single-purpose cast-iron tri-squares, wooden folding rules, and crude dividers that quickly wore out or deflected under pressure. Starrett recognized that the industrial future depended entirely on dimensional accuracy. He decided to dedicate the rest of his life to perfecting the science of physical measurement. The foundation stood firm. Modern metalworking hit a frustrating mechanical bottleneck across New England during the late 1870s. Factories were trying to manufacture high-speed steam engines, sewing machines, and interchangeable firearms, but machinists were trapped in an era of manual trial-and-error fitting. To align a workpiece on a planer or lathe, a machinist had to shuffle between 5 different heavy tools: a fixed tri-square for right angles, a miter square for 45-degree angles, a separate depth gauge, a wooden ruler, and a standalone bubble level. Every time a worker picked up a different tool, subtle alignment errors stacked up, wasting precious shop hours and ruining expensive forgings. Furthermore, traditional wooden and soft steel rules expanded with temperature changes and rusted easily, obscuring their crude stamped graduations. Starrett attacked this mechanical bottleneck with brilliant simplicity. In 1877, he patented the world's first true combination square. Instead of joining fixed pieces of metal together, Starrett designed a hardened steel rule with a continuous precision groove milled down its center. Onto this rule slid a drop-forged cast-iron head featuring precisely ground 90-degree and 45-degree reference faces. A spring-loaded thumb-screw mechanism clamped into the center groove, locking the head tightly at any position along the blade, without shifting a thousandth of an inch. To complete the breakthrough, Starrett embedded a sensitive spirit-level vial directly into the cast head and concealed a hardened steel scribing pin in its base. One elegant, rock-solid instrument replaced an entire box of clunky tools. Think about what that meant for a machinist. A layout job that previously required an expert machinist 4 hours of careful hand-feeding could now be executed in seconds with surgical precision thinner than a silk filament, less than 1/30th the thickness of a single sheet of printer paper. Consider the monumental task of building a global brand on unyielding precision. Starrett did not stop at the combination square. He pioneered the satin-chrome finish on tempered steel rules, eliminating harsh shop floor glare and protecting the etched lines against rust and oil corrosion. He expanded his tool line to include ultra-precise spring calipers, height gauges, dial indicators, and Vernier micrometers capable of measuring down to 1/10,000th of an inch. At his growing Athol plant, Starrett established complete vertical integration. He built his own specialized machinery to photo-engrave graduation lines onto steel rules with absolute mathematical perfection. Every single tool that left the factory was hand-inspected under magnification against master standards. If a micrometer screw demonstrated even a microinch of lead error, the instrument was immediately pulled off the line and torn down to the bare metal. Quality was his religion. Overwhelming commercial success quickly followed Starrett's breakthrough. Within a decade, the L.S. Starrett Company became the undisputed global standard for precision measuring instruments across all major manufacturing industries. Machinists across North America and Europe viewed owning a red leatherette Starrett box not just as purchasing a tool, but as acquiring a sacred badge of professional craftsmanship. Independent mechanics saved their hard-earned wages for months just to buy a Starrett micrometer or combination square. They knew that once that satin-chrome steel instrument entered their wooden tool chest, it would deliver flawless accuracy for 50 years without losing its edge. World War I and World War II erupted in rapid succession, launching the ultimate test of human stamina and industrial capability. Almost overnight, the United States military transformed the domestic manufacturing sector into the arsenal of democracy. Millions of warplanes, heavy tanks, naval artillery pieces, sub-chasers, and ammunition shells had to be produced at speeds never before attempted in human history. But high-speed mass production demands absolute, unyielding interchangeability. A cylinder head manufactured in Detroit had to fit perfectly onto an engine block cast in Connecticut and be installed on an airfield in Europe without a single thousandth of an inch of hand filing. Defense officials on the War Production Board declared the L.S. Starrett Company a top priority national defense asset. The massive brick plant stretching along the Millers River in Athol transformed into a high-intensity, 24-hour production center. Shift after shift, thousands of skilled toolmakers, engravers, grinders, and draftswomen worked continuous hours under blackout curtains. The factory forge fires roared non-stop, drop-forging tool steelheads while specialized dividing engines engraved millions of precision steel rules day and night. The work was demanding, loud, and unforgiving. During severe winter freezes and wartime material shortages, Starrett workers slept on wooden crates beside warm, annealing ovens to keep production lines moving without losing a single productive hour. Continuous mechanical motion roared across every square foot of the factory floor. Master engravers etched microscopic graduations onto satin-chrome rules, while inspectors verified micrometer screw threads using optical comparators and optical flat gauges under monochromatic light. The Starrett Company supplied over 80% of all precision measuring instruments used by Allied military machine shops and defense plants worldwide. Their micrometers verified the exact tolerances of Boeing B-17 Flying Fortress crankshafts, Curtiss P-40 fighter engines, and Rolls-Royce Merlin turbine shafts, while their combination squares aligned the structural armor plating of Sherman tanks. The Pentagon issued strict priority directives to ensure Starrett shipments were never delayed by rail congestion. The United States military awarded Starrett the prestigious Army-Navy E Award for Extraordinary Achievement in Wartime Production, adding multiple white stars as the conflict progressed. They held the line. Precision was their weapon. Recalling that dark November evening in 1877 brings us back to the opening mystery of Starrett's survival. The foreclosure notices on his table represented only the visible surface of his struggle. What the public never saw during Starrett's rise was the vicious, multi-year legal battle waged against him by former partners and rival tool manufacturers. They tried to destroy him before his combination square could take market root. Rival tool manufacturers and former business partners launched an aggressive war against Starrett when his combination square began outselling traditional tri-squares. Driven by greed, his former investors realized they had cast aside a $1 million invention and filed aggressive patent infringement lawsuits. They claimed that Starrett had stolen the combination concept from old woodworking tools. At the same time, rival manufacturers began producing cheap knockoffs made of soft pig iron and crude sheet metal, flooding hardware stores with counterfeit tools carrying forged markings. They attempted to bankrupt Starrett through overwhelming court expenses while undermining his reputation for quality. Inventing an entirely new category of precision hand tool proved to be Starrett's ultimate legal weapon. Starrett was not merely a brilliant mechanical designer. He was an untamed legal warrior. He stood his ground. Rather than settling or backing down, Starrett spent his last remaining dollars hiring top patent attorneys and personally constructing physical demonstration models for the courtroom. In a landmark federal trial, Starrett proved that his patented center groove locking mechanism and drop-forged head were fundamentally unique engineering achievements. The court ruled decisively in his favor, issuing strict injunctions against his former partners and granting Starrett exclusive control over the combination square. Behind locked steel doors, Starrett executed his quiet, decisive revenge. He quietly bought out his former company's assets at auction after they collapsed into bankruptcy, walking back into the very factory that had evicted him years earlier as its sole owner. He proved that true engineering brilliance married to unyielding personal integrity will always conquer corporate deceit. He took the hint. The secret legal victory ensured American tool supremacy for a century. The court records preserved his triumphant victory for future generations of craftsmen, establishing the iconic red box as sacred ground for machinists. The verdict was final. The rule ran true. Untouchable industrial excellence defined the Starrett Company for nearly a full century. But as the world entered the late 20th century, the manufacturing landscape began to undergo a turbulent, destabilizing shift. The global economy was flooded with low-cost overseas imports, particularly cheap digital calipers and electronic measuring tools manufactured in East Asia. Foreign competitors produced inexpensive plastic and stamped steel measuring devices that appealed to budget-conscious consumers, and corporate purchasing departments focused purely on upfront price tags. Automated assembly lines and disposable digital sensors simultaneously transformed modern manufacturing culture. Traditional apprenticeship programs that taught hand scraping, vernier reading, and mechanical feel were increasingly replaced by automated assembly lines. Wall Street financial metrics, private equity mindsets, and quarterly earnings pressure began exerting heavy demand on traditional domestic toolmakers. Corporate managers pushed to reduce labor costs, outsource manufacturing to low-wage regions, and replace heavy drop-forged tool steel with cheaper lightweight components. Executives focused on short-term profit margins and corporate restructuring rather than reinvesting in shop floor metallurgy and master craftsmanship. Relentless market pressure forced many historic American tool companies to fold, sell out, or transfer their production overseas. Starrett resisted this shift longer than almost anyone else, fighting fiercely to preserve its historical factory footprint in Athol, Massachusetts. However, the company faced relentless market pressures, corporate restructuring, and the harsh economic realities of a world that increasingly valued cheap convenience over permanent quality. The iconic Athol plant saw shift reductions as commercial markets were overwhelmed by cheap plastic gadgets. Wall Street investors demanded lower overhead, while offshore factories flooded job shops with disposable tools. Corporate raiders dismantled what a century of master machinists had built. The global empire of precision steel was challenged by corporate spreadsheets. Enduring resilience defines the true philosophy of hardened steel tools. Corporate headquarters may undergo restructuring, market trends may favor disposable digital gadgets, and factory ownership may shift over time. But the physical steel that Laroy S. Starrett designed and manufactured a century ago refuses to yield. Walk into any high-end aerospace shop, nuclear facility, or master machinist's workshop today. In the top drawer of a classic wooden tool chest, you will inevitably find a vintage LS Starrett combination square or micrometer, carrying a generosity of structure that bordered on excess. Outfitted with satin-chrome finishes and ground reference faces, these vintage steel instruments still measure stainless steel, titanium, and bronze day after day without flinching. Modern plastic digital calipers might flicker, lose battery power, or flex under thumb pressure, but a 100-year-old Starrett ground steel rule locked inside a drop-forged cast head does not budge. Machine shops know that when an impossible aerospace contract arrives with sub-thousandth tolerances, the ancient Starrett rule will read true without missing a beat. The founders are gone, the original steam engines are silent, and old stock certificates are paper relics. The company underwent trials. The tools outlived the empire. Appreciating this forgotten history is what Rivet and Rebar is all about. Thank you for watching. If you enjoyed discovering how an evicted farmer invented precision measurement and built an industrial legend, click the video on your screen right now to explore another incredible saga of forgotten engineering might.